Everyone, let us do some assertion reason questions from the lesson Coordination Chemistry. Here, the first question, NF3 is a weaker ligand than NCH3 thrice. Reason, NF3 ionizes to give F- ions in aqueous solution. NF3 is a weaker ligand because NF3 is a weaker Lewis base. We know to nitrogen 3 fluorine atoms are connected and nitrogen has a lone pair. Here the electron density of nitrogen atom decreases because 3 fluorine atom, each fluorine is electron withdrawing. So electron density in NF3 decreases. Whereas in NCH3 thrice, 3 CH3 groups are connected to nitrogen. CH3 groups are electron releasing groups, so that increases the electron density on nitrogen atom. So NCH3 thrice can act as a good Lewis base compared to NF3. So first statement is correct statement. Ligands are Lewis bases. NF3 ionizes to give F- in aqueous solution. NF3 is a covalent compound, so it does not give rise to ions in solution. So that statement is wrong statement. So our option is C. Second question, FeCN6 3- is weakly paramagnetic while FeCN6 4- is diamagnetic. We know the oxidation state of iron and also the oxidation state of FeCN6 3- is given as +3, FeCN6 4- has +2. So let us verify this. Fe plus 6 cyanide, 6 into -1, so -6, which is equal to sum will be -3. So Fe is equal to -3 plus 6, that is equal to +3. So first statement, first oxidation state is correct. In FeCN6 4- Fe plus -6 equal to sum is -4, and so the oxidation state of Fe is -4 plus 6, that is equal to +2. That is also correct. So the statement is correct. FeCN6 3- is weakly paramagnetic. Iron, its electronic configuration is argon 4s2 3d6. In +3 oxidation state, you have to remove 3 electrons, 2 from 4s2 and 1 from 3d6. So remaining electrons 4s0 3d5. 5 electrons are there, and cyanide is a strong ligand. So we have to pair the 5 electrons. When we pair the 5d electrons, we can see 1 electron is single. Because of that, we can say that is weakly paramagnetic. So that is correct statement. FeCN6 4- is diamagnetic. Then in +2 oxidation state, we have to remove only electron from 4s orbital, so 4s0 and 3d6. So 3d6 means all the 6 electrons are paired because of the strength of the ligand. Cyanide is a strong ligand. All electrons are paired, so no unpaired electron. So that's diamagnetic. That's also correct. Assertion statement is correct. Reason statement also correct. But reason is not the correct explanation of assertion, because we know paramagnetism and diamagnetism depends upon paramagnetism depends upon unpaired electron, and diamagnetism means all the electrons are paired. So our option is B. Then hexaaqua titanium is colored while scandium hexaaqua scandium is colorless. DD transition is not possible in hexaaqua scandium. First, scandium, its atomic number is 21. So its electronic configuration argon 4s2 3d1. In scandium complex, it is in +3 oxidation state. So we have to remove 3 electron, 2 from 4s and 1 from 3d. So there won't be any electron in the outer shell because it will get the noble gas configuration. So DD transition is not possible in scandium complex. That statement is correct. Titanium, we know its atomic number is 22. So argon 4s2 3d2. In titanium complex, it is in +3 oxidation state. So we have to remove electron from 4s orbital and 3d, balance 1 electron is there. So dd transition is possible, so it is colored. So assertion and reason, both the statements are correct statements only. So, and reason is the correct explanation of assertion. So our option is A. Toxic metal ions are removed by chelating ligand. Chelating ligand chelate with the metal ion, it forms stable complexes. So that statement is correct. Chelate complexes tend to be more stable, that's also correct, because chelate ligand make more stable complexes with the metal ions. So assertion and reason both are correct statements, and reason is the correct explanation of assertion. So our option is A. Next, linkage isomerism arises in a coordination compound containing ambidentate ligand. So that is a compulsory condition for showing linkage isomerism. That is correct statement, because we know for ambidentate ligand, for example SCN, it has two connective sites. Either we can use S or we can use N. So ambidentate ligand has two different donor atom. Because of that only it is showing this isomerism. So assertion and reason, both the statements are correct, and reason is the correct explanation of assertion. So our option is A. Next, complexes of MX5 L type do not show geometrical isomerism. That is a correct statement, because here the ligands are identical. At least one pair should be different. Here all the 6 ligand unidentate ligands are identical, and here 5 ligands are identical. So it cannot show geometrical isomerism. That statement is correct. Geometrical isomerism is not shown by complexes of coordination number 6. That is a wrong statement. We know octahedral complexes show geometrical isomerism or cis-trans isomerism. So assertion correct and reason wrong. So our option is C. 7th question. Nickel cyanide is a square planar and diamagnetic complex. It has no unpaired electron due to the presence of strong ligand. Cyanide is a strong ligand, and nickel, its electronic configuration is argon 4s2 3d8. In NiCN4 2 minus, nickel plus 1 cyanide, oxidation state -1, so 4 cyanide -4, sum is -2. So nickel is equal to -2 plus 4, that is equal to +2. In NiCN4 2 minus, nickel is in +2 oxidation state. That means we have to remove 2 electron from 4s2. So it will be 4s0 3d8. So we have 8 electron, and cyanide is a strong ligand, so we can pair the electrons. So one d orbital is available for bonding, so it can make dsp2 hybridization, because its coordination number is 4. So it's square planar, correct statement, and diamagnetic, all the electrons are paired, that's also correct. It has no unpaired electron due to the presence of strong ligand. Assertion and reason both are correct statements, and reason is the correct explanation of assertion. So our option is A. Next question. Oxalate ion is a bidentate ligand. That's correct statement. We know the structure of oxalate, COO minus, COO minus. Here 2 donor atoms are there. So both can be used for connecting to the metal. So oxalate ion is a bidentate ligand. It has 2 donor atoms. Both assertion and reason, both the statements are correct. So our option is, and reason is the correct explanation of assertion. So our option is A. Next, FeF63 minus is a low spin complex. Low spin complexes have lesser number of unpaired electron. For that, let us find out the oxidation state of iron in FeF63 minus. Iron, its electronic configuration argon 4s2 3d6. Here in this complex, the oxidation state of iron is +3, because We know 6 fluorine atom, that will make minus 6 plus x sum is equal to minus 3. So x equal to minus 3 plus 6, that is plus 3. So we have to remove 3 electron from 2 from 4s and 1 from 3d. So we will get 4s0, 3d5. So we will get 5 unpaired electron because fluorine is a weak ligand. All electrons are singly occupied. Because of that, it's a high spin complex, but it's written here low spin complex. So that statement is wrong statement. Low spin complexes have lesser number of unpaired electron. That statement is correct statement because high spin has more unpaired electron, low spin has lesser number of unpaired electron. Assertion wrong and reason correct. Our option is D. F minus is a weak ligand and forms outer orbital complex. In the previous case we saw F is a weak ligand, so pairing of electron does not take place. So it can utilize the outer orbital for bond formation. So that statement is correct statement. F minus cannot force the electron dz square, dx square, y square orbitals of the inner shell to occupy dxy, dyz and dz orbitals of the same shell. That statement is also correct. So assertion and reason both are correct statement and reason is the correct explanation of assertion. So our option is A. Next one. NiEn thrice Cl2 has higher stability than NiNH3 6 times Cl2. The statement is correct because we know En is a didentate ligand. Didentate or polydentate ligand or chelate ligand form more stable complexes compared to complexes with the unidentate ligands. In NiEn thrice Cl2, the geometry of nickel is trigonal bipyramidal. That is wrong. So assertion correct and reason wrong. Our option is C. Next, the ligands cyano and nitrito are called ambidentate ligands. They have two connective sites, so they are ambidentate ligands. Cyanide nitrogen can be used for connection or carbon. Here oxygen and nitrogen, so they are ambidentate ligand. And they show these ligands give linkage isomerism. That's correct statement. So the condition for showing linkage isomerism, the ligand should be an ambidentate ligand. So assertion and reason both are correct statements and reason is the correct explanation of assertion. Then next question. Geometrical isomerism is also called as trans isomerism. That statement is correct statement. Tetrahedral complexes show geometrical isomerism. That's wrong statement. For tetrahedral complexes, the relative positions are identical, so it cannot show geometrical isomerism. So assertion correct and reason wrong. Our option is C. FeCN6 3- is weakly paramagnetic. So FeCN6 3- iron is in 4s2 3d6 and here the oxidation state of iron in the first complex, it is plus 3 because Fe plus minus 6 equal to minus 3. Fe is in plus 3 oxidation state. That's correct. In FeCN6 for minus, that is also correct because Fe plus minus 6 is equal to minus 4. So Fe is in plus 2 oxidation state. So reason both oxidation states are correct. And cyanide is a strong ligand. So in the first case you have to remove 3 electron, remaining 3d5. We removed 2 electron from 4s2 and 1 from 3d. So we got 3d5. So when we write the electronic configuration, we can see 5 out of 5 electron, 2 are paired and 1 single electron. Because of that it's weakly paramagnetic. Whereas in the second case we removed only 2 electrons, so we have 3d6 configuration and all electrons are paired, so no unpaired electron, so it's diamagnetic. So assertion statement is correct, reason statement is also correct, but reason is not the correct explanation of assertion because we know paramagnetism and diamagnetism depends upon unpaired electron. Paramagnetism means there should be unpaired electron, but dia means all the electrons should be paired. So our option is B. Next, the complex CONH3 tri-Cl3 gives no precipitate with the silver nitrate ions. That statement is correct because here we can see only the complex part, that's non-ionizable. Only counter ion we can ionize. So that statement is correct statement. The given complex is non-ionizable, that's why it cannot produce ions, chloride ions. If we have chloride ions only, it will answer the test for chloride with the silver nitrate. So assertion and reason both are correct statements, and reason is the correct explanation of assertion. So our option is A. Next, NiCl4 2- is paramagnetic, whereas NiCO 4 times it is diamagnetic, though both are tetrahedral. We know in the case of NiCl4 2-, the oxidation state of nickel there it is +2, because we know chlorine is in -1 oxidation state, 4 chlorine -4. So -2 + 4 it is +2. Nickel is in +2 oxidation state. So nickel electronic configuration, outer electronic configuration 4s2 3d8. You have to remove 2 electrons, so remaining electrons are 3d8. And chlorine is a weak ligand, so pairing of electron does not take place. So we have 8 electrons. Let us give one electron to each d orbital, and the remaining electrons we can pair according to Hund's rule. So we have 2 unpaired electrons, because of that it is paramagnetic. Whereas in NiCO 4 times, CO is a neutral ligand, so oxidation state of nickel is 0, because the sum should be 0. So nickel 4s2 3d8, we are not removing any electron, and since CO is a strong ligand, it will force the 4s electrons to 3d, and 3d orbital we have 10 electrons, and all the 10 electrons we can see as pairs. So no unpaired electron. So it is diamagnetic. So assertion statement is correct, reason also correct, and reason is the correct explanation of assertion. So our option is A. Next question. More salt is not a coordination compound. The aqueous solution of the salt gives the test for Fe2+, NH4+, and SO4 2-. More salt is a double salt which is completely ionizable into Fe2+, SO4 2-, then again SO4 2-, and NH4+, NH4 twice, SO4, so NH4+. So this is correct, and this is also correct. Assertion and reason both are correct statements, and reason is the correct explanation of assertion. Only double salts are ionizable, coordination compound is not ionizable. Cisplatin is used for inhibiting the growth of tumors. Cisplatin is a coordination compound. Its medicinal use, it can be used for inhibiting the growth of tumors. It's a coordination compound of platinum which inhibit the growth of tumors. That statement is also correct, but reason is not the correct explanation of assertion. So our option is B. Next question. The coordination number of cobalt in COEN thrice 3+ is 3. That's wrong statement, because En is a didentate ligand. We have 3 didentate ligands, so 3 into 2, 6. Coordination number is 6 here. So that's wrong statement. En is a didentate ligand. So assertion wrong and reason correct. Our option is D. EDTA is used for determining the hardness of water. Yes, that's correct statement. EDTA is a chelating ligand, and hard water contains calcium and magnesium ions. So calcium and magnesium ions form stable complexes with the EDTA. That's correct statement. EDTA is a bidentate ligand. That's wrong. EDTA, it's a hexadentate ligand, or we can call it as polydentate ligand. So assertion correct and reason wrong. Our option is C. Then AuCN twice is used for gold plating. That's correct statement. If we add zinc to AuCN twice, gold metal will be obtained, because zinc will displace gold. So that statement is correct statement, but reason is not the correct explanation of assertion. So our option is B. Hypo is used to remove an undecomposed silver bromide from photographic film. That's correct statement. Hypo is used as a fixer and forms complex with the silver bromide. That is also correct statement, because we will get Na3AgS2O3. So when we write in ionic form, AgS2O3 3 minus, so that is also correct. So assertion and reason both are correct statements, and reason is the correct explanation of assertion. So our option is A. The energy difference between two sets of d orbital is called crystal field splitting energy. That's correct statement. For octahedral complex, we will write delta O, and tetrahedral we will write delta T. But we know delta O is greater than delta T, but here it's written delta O is equal to 4 by 9 delta T. That's the opposite. Delta T is equal to 4 by 9 delta O. So here assertion correct and reason wrong. So our option is C. Next, dx square, y square and dz orbitals have higher energy than dxy, dxz, dyz orbitals in octahedral field. Yes, in octahedral field, the Eg orbitals are having higher energy than T2g. That's correct statement. Whereas in tetrahedral complexes, we can see T2g is having higher energy than Eg. So both statements are correct, but reason is not the correct explanation of assertion. So our option is B. Greater the strength of ligand, greater will be delta O. Yes, of course, because crystal field splitting depends upon the strength of the ligand. So assertion is correct. If delta O greater than P, P stands for pairing energy. So pairing energy is less, so the electron will go for pairing. Then the configuration is T2G3 Eg2. That's wrong. We will get T2G5. So assertion correct and reason wrong. Our option is C. Next, the series in which ligands are arranged, the increasing order of their strength is known as spectrochemical series. That's correct. Delta T is equal to 4 by 9 delta O. That statement is also correct, but reason is not the correct explanation of assertion. Next question. Hemoglobin is a coordination compound present in blood. That is correct statement. Hemoglobin contains iron which is responsible for red color in blood. That is also correct statement. Then assertion and reason both are correct statement, but reason is not the correct explanation of assertion. So our option is B. Next, tetrahedral complexes are generally more stable than octahedral. Reason crystal field splitting energy is greater in octahedral complexes. So first statement is wrong statement, because tetrahedral complexes are generally, we cannot say it's more stable than octahedral complexes. Crystal field splitting energy is greater in octahedral complexes compared to tetrahedral. That's correct statement. So assertion wrong and reason correct. Our option is D. Next question. Out of NH3 and CO, the ligand that forms a more stable complex with a transition metal is CO. Yes, that's correct statement, because we know CO, it has synergic bonding or back bonding, because it forms stable complex than NH3 because it is involved in synergic bonding or back bonding. So both assertion and reason statement both are correct, and reason is the correct explanation of assertion. Then next question. CONH3 6 times 3 plus is more stable than COEN thrice 3 plus. That's wrong statement, because NH3 is a unidentate ligand and EN is a didentate ligand. So didentate or chelate ligand form more stable complexes. So assertion is wrong. EN is a didentate ligand, NH3 is a unidentate ligand. That statement is correct. So assertion wrong and reason correct. Our option is D. Next question. Colored complexes become colorless once the ligands are removed. That's correct statement, because color is due to crystal field splitting and DD transition. In the absence of ligand, the crystal field splitting won't happen, and DD transition is also not possible. Here the DD transitions are not possible since d orbitals become degenerate. They have same energy. So assertion and reason both the statements are correct. Reason is the correct explanation of assertion. Next, EDTA is used to treat lead poisoning. Yes, EDTA is a chelate ligand. It can make stable complexes with a metal. EDTA form very stable complexes with lead. So assertion is correct, reason is also correct, and reason is the correct explanation of assertion. So our option is A. Nickel tetracarbonyl has square planar geometry, while nickel cyanide has Tetrahedral geometry. Nickel, its electronic configuration argon 4s2 3d8. In nickel tetracarbonyl, carbonyl is neutral ligand, so nickel is in zero oxidation state, so you don't have to remove any electron. We have 10 electron, and since CO is a strong ligand, 4s electron will be shifted to 3d8 as a part of strong ligand will force the electron for pairing. Then we will get 3d10. So all electrons are paired, because of that it is diamagnetic. And it's not square planar, because square planar the hybridization should be dsp2, but here no d orbital available for bonding, so that is wrong statement. Geometry of any complex depends upon the nature of ligands attached, that's correct statement. So we know the hybridization can vary depending upon the strength of the ligand. Assertion wrong and reason correct. So our option is option D.